Hello everyone. I'm audible. Okay, great. So let's start today's issue discussion. We are going to discuss all of the five problems of today's issue. So yeah, let's start with the first question. Right. Where is the code? Okay, yeah. So let's start. The first question is: Chef has a string of length n. The exact contents are irrelevant. Only the length matters. Given two parameters a and b, chef does the following repeatedly. While the string is of length a, of length at least a, he chooses a substring of length A from the string and replace it with a substring of length B. And it is guaranteed that B is less than A. So this process will eventually terminate as the string will always decrease in size. And we need to find the final length of the string when it terminates. So we are given three integers n, a, and b. Right. Question one: We have a string. We have a string s with length n. That's one s like this. Is n. And we have an integer a, we have an integer b, right? So what we can do is we can choose a substring of length a and replace it with a substring of length b. Okay. And it is given that a is always greater than b. So whenever we replace this substring of length a with a substring of length b, the length of this string will decrease. We are taking out any a characters and we are adding b characters. So the string's length will always decrease. So this process will terminate. Now, since it doesn't matter whatever the string is, we can simply say that we have a number n, and what we are doing is we are decreasing in one operation. We are decreasing a from it. So n will be n minus a, and we are adding b to it, and n plus b. And to do this operation, given with n is greater than equal to a. Whenever n is greater than equal to a, we can do this operation, right? And we need to output the final value of n. So the constraints in this problem that is given are n is less than equal to 100 and a and b are also less than or equal to 100. So if we run a brute force for this, for up to while n is greater than or equal to a, if we simply do this, it won't be an issue as the given constraints are less. The time complexity for this will be how many times this particular operation can happen. In suppose in one operation the length is decreasing by one, n is, or you can say n is decreasing by one. It is also, as we have seen, that n will always decrease. So let's say n decreases for some n times O of n, right? This will be an O of an operation into test cases, as n is not restricted on test cases. So this is a very simple time complexity. This is a very simple brute force solution. If you don't want to do brute force, another thing that you can think of using math is, what we are doing is, in n, we are always decreasing a minus b, right? In n, we are always decreasing decrease n by a minus b. Correct? Sorry. We are always in decreasing n by a minus b. Right. So if suppose whatever the number n is, like we need to find a number x, let's say, that is greater than, oh, sorry, that is less than n, the maximum x that is less than n, whose percentage with this particular number is same. That is what we need to find, right? As whenever we decrease this a minus b, its its remainder with a minus b will not change, right? So we need to find a number x which is less than n, the maximum number x which is less than n, which has the same remainder when divided by a minus b as n. So that's what we need to find. And to do that, what we can do is we can simply first of all take n, right? And sorry, that is less than or equal to not n, that is less than or equal to a, right? Sorry, that is less than or equal to a. So yeah, first of all, yeah, first of all we will find a number, we will find a number y that is greater than or equal to a, and that gives same remainder as this, and then we will simply decrease a minus b from it. So we will get bx. This is the math solution. You can try to implement it. Otherwise, the brute force, of course, always works. Yeah. So that was the first problem. Now let's move on to the second problem. Yeah. You are given an array A of n integers. You can perform the following operation at most three times. You can choose two indices I and j such that I is less than j and set the value aj to ai. And now what we need to do is find the minimum number of distinct elements that could be left in A after performing at most three operations. Okay, so first of all, let us just ignore this condition. Let us just ignore this particular required condition. Okay, so if we just ignore this, what will be our answer? Let's first of all discuss that. Okay, so in question two, what you have is you are given an array A of length n, and ignoring this condition, what we have is just set take an I and take a j, and we have to set aj equal to ai, right? So suppose this is some ai, this is some aj. What we can do is we can copy one particular value to another, right? And what we need to do is we need to minimize the number of distinct elements, right? Now, if you know the solution to this problem, it is very easy. And if you don't know, let us first of all discuss it. Uh, if you can copy one element to another without any constraints, and you need to minimize the distinct elements, what first of all we need to say is, suppose we are copying some AI to AJ, right? So what's happening here is we are taking some AI and we are copying it to AJ. So what will happen is the number of occurrences of AI, or you can say that count of AI, will increase by one after doing this, and count of AJ will decrease by one, right? That's what will happen, right? If you do one particular operation of AI to AJ, then count of AI will increase. Count of AI in the array, the number of occurrences of AI in the array will increase, and the number of occurrences of AJ in the array will decrease by one. So what you want to do is you want to just remove one particular element, right? To make the number of distinct elements lesser. What you will need to do is You will first of all you will pick one particular element. Let's say you pick some ax, right? You removed one of its occurrences. Then you removed another of its occurrences. Suppose it has four occurrences, right? You will need to remove all of these four occurrences to be able to change your answer or to be able to decrease your answer. That is, to be able to decrease your number of distinct elements, right? You will need to eliminate all of these four occurrences of AX for the change in your answer, right? Uh, in one operation, you can eliminate one occurrence of AX, and in four operations, you can eliminate all four occurrences of AX. So first of all, whatever array we were given, we will first of all count the number of occurrences of all of the AIs. You can do it using a map, right? You can do it using a map, you can combine whatever. Yeah, you can do it using a map. What you can do is you can simply store its number of occurrences. So for every AI, you will have its count, right? Here you can see. So for every AI, you will have a count of this particular AI. Now, what we can do is we will see a particular AI which has the least count, right? Suppose there are four AIs that are 1, 2, and 5. Suppose one occurs five times in the array, two occurs three times, three occurs two times, and four occurs four times. Let's say this is our map after doing all of this. So, yeah. So, suppose you have five occurrences of one, three occurrences of two, two occurrences of three, and four occurrences of four, let's say, right? So what we have seen is to decrease our distinct a number of distinct elements, to decrease our number of distinct elements. What we will need to do is we will need to do the count of some particular AI or those number of iterations. So suppose you want to terminate three from the array, you want to eliminate three from the array, right? So what you will do is you will take these two, occurrences of three, and you will convert them to any one of these numbers, right? You will take the two occurrences of three and you will convert it to any one of these numbers. How many operations will it require? It will require the count of three operations, right? It will require the count of that particular number of those operations. So, greedily we can see that if any element has the least number of occurrences, if any element has the least number of occurrences, then we will first of all eliminate that particular element only, right? So we will simply take these number of occurrences. We don't care about what the element is, right? As we need to just find the number of distinct elements. So you will take the number of occurrences of the elements, you will sort them. After sorting, you will get something like 2, 3, 4, and 5, right? After that, you will start performing operations. Now, one more thing that you need to see here is the last number, that is 5, will always be there in the array. Suppose there is an element with five occurrences in the array. Right. After all the operations, there will always be one element that will be remaining in the array. Right. Suppose this was the array, right? Array had five ones, three twos, two threes, and four fours. After we have performed all the operations, there will be at least one distinct element. And for that one distinct element, you will like to not perform the operation on that particular element, right? So in this case, this is that element that we will like to not perform on any operation on, as it is the largest, right? So what we will do is we will take one particular element, we will convert it to the greatest, the element that has the largest number of occurrences, correct? So simply suppose K is 4 here. What you will do is the first two operations you will take. to remove these two occurrences of a particular element, and the number of the number of distinct elements, let's say f of a is the number of distinct elements of a, it will decrease by one, right? If we remove these two occurrences of a particular element, the number of distinct elements that were four earlier will now decrease to three after two operations, and now we have two operations left. And as we can see that using these two operations, we cannot do anything, right? Suppose these operations were five initially. What we will do is we will first remove the two occurrences of two and add it to five. So the five will become three then. And after this, we will take these three occurrences, right? We have three left. So we can take the three occurrences and we can add it to five to further reduce our number of distinct elements by one. So f of 4, 5, it was initially 4, and it becomes 3, and it becomes 3. Right. So this was the greedy logic without this, without this condition. Now what happens if we include this condition? Okay. Now what we are doing earlier is we took the occurrences of all the elements. We took the number of occurrences of all the elements, right? We took count of AI of all the elements and we sorted this count, right? So we had the smallest count, we had the another count, and then we had another count, and then we had another count. What are these numbers? These are the count of one particular element in the array, right? Now, since what we are doing is we are restricting this operation such that uh, I is less than j, right? And you need to set the value of aj to ai. Okay. Suppose I is less than j, right? This was ai and this is aj now. J is greater than I or I is less than j, whatever. Yeah. So j is less than I, and now what we will do is we will set the value of ai to aj. Now, in our previous problem, it didn't matter wherever I or j is. We will simply uh, we will simply convert one element to another without seeing if it comes before or after that particular element. Now, in this particular case, right, what will happen is suppose this is the array for this particular I, or sorry, for this particular j, what you need to do is you can convert this element to any element which comes before it only, right? To convert the jth element to any other element, you can convert it to any element which comes before it. So this is the restriction. You cannot convert it to any element which comes after it. So let us see the first element of the array. This is A1. Can we change this element? Since this is A1, it doesn't have any element before it. Okay. A1 doesn't have any element before it. So you cannot change A1 in this system. Right? This was the question. Suppose we took this array 1, 2, 2. 1, 2, 2 we took. How many operations you need to perform? Suppose there is 3 and 5 also here. Whatever operations you want to perform, you can perform. But the thing is that you cannot change this one. This one will always remain same. That is, A of 1 will always be 1. Whatever you want to do, as A1 does not have any element before it. So if you see this, you will notice that we need to find the number of distinct elements, right? Number of distinct. We need to find number of distinct elements. And now, since you cannot change A1, since you cannot change A1, the element which is at A1 will always be there in the array, right? The element that is at A1 will always be there in the array. So what you want to do is you will again do the same thing that you did earlier. Just the thing is that you can convert any element to one only. Suppose A1 was one here. So you will take any element and you will convert it to one. This will not affect our solution as one will always remain in the array, whatever we want to, right? So you will take any AI, you can take any AI and convert it to A1, right? As the count of A1 will always be greater than or equal to 1 as the first element cannot be changed. So you can just take the AI and take it to A1. And in this manner, we can decrease the occurrences of AI, right? So now also we will do the same thing that we did earlier. We took some count of AI, some AI, and then the count of some AJ, and then count of some AK, count of some AK, and something like this. We made an array of this, right? Or we made a map of this. Now what we see here is we cannot eliminate the first element. So we will just remove the first element from this map. Suppose this AJ was the first element. So we will just erase this from the map. As we cannot terminate this particular element to zero. The number of occurrences of this particular element to zero. As we cannot terminate the occurrences of this particular element to zero. So we will just remove it from the map. Okay. So AJ is gone. Now we have the same thing. We have some counts of some elements. We will first of all sort it. And after that, we will do the same thing, right? Earlier, what we were doing is we took one element, we converted it to the element that has the largest occurrence. And now what we will do is we will not convert it to the largest occurrence. We will convert it to the element A1. We will convert it to A1. Okay. So that is the logic to this question. I hope it's clear to everyone. Okay. So where will we? Yeah, minimum distance. So that was the logic. Where is my okay, so here is the code for the same. You first of all took input of all the elements. Yeah, you stored its references in a map using a map. And now, since you cannot remove the first element, you will remove the all occurrences of the first element from the map, right? And then you will do the same thing. You will simply push back all of the occurrences, number of occurrences in a vector. You will sort it wherever sorted. Yeah, you will simply sort it. Oh, I think it should come before you. Yeah. So you will simply sort the number of occurrences, and if you can eliminate one particular element, what is IT? IT is a count of any element in increasing order. So if IT is less than equal to k, you can eliminate that element. So you will simply eliminate that element. That is, you will decrease your number of distinct elements by one, and k, and it will require IT number of operations. The number of occurrences. That is the number of operations that you will need. So you will decrease it from k, and whenever k is greater than the required number, you will simply break it, and that's the answer to this. What's the solution to this question? Okay. So now let's move to the third question. Yeah. You are given an array A of n integers. You can perform the following operation as many number of times as you want. Choose an index I and you can multiply AI by 2, right? And you need to find the minimum possible value of max AI minus min AI. And you can achieve this through the use of operations. Okay. So, first of all, yes. So here in third question, what we are given is we are given some elements, right? You are given some elements. You can take one particular AI and you can change it to AI into 2. And now what you need to do is you need to find the maximum of A minus the minimum element of A, right? That is what you need to find. And minimize this thing. You need to minimize this particular thing, right? I hope the question is clear to everyone. And now let's see what we can do. Okay. So first of all, suppose the current minimum of the element of the array A is AI. Okay. The AI is current min. Okay. AI is the current minimum. And suppose AJ is the current maximum. Okay. Okay. So what is this value currently? The value is AJ minus AI, right? This is the value. And now what you need to do is you need to somehow decrease this. Okay. So what you can do is you can multiply 2 to any number. So if you multiply 2 to any number other than these two numbers, if you multiply 2 to any number other than these two numbers, then it won't matter. Okay. If you multiply 2 to this AJ, then of course this will increase. So what you can do is you can simply multiply 2 to AI and this will decrease. Like you are multiplying AI by 2. So you will take the minimum element of A, you will multiply it by 2. And you will do this as many times as possible. How many times? You will do this while this particular thing, AI into 2, while this particular thing is less than or equal to AJ, you will just do it. You will just do it. You will just multiply AI by 2, right? What is AJ? AJ is the maximum element of the array. Of course, you don't want to multiply 2 to the maximum element of the array, right? So, of course, you don't want to multiply 2 to the maximum element of the array. So, while you can do this particular operation for any element of the array, you will simply do it, keeping it less than AG, right? So, while this thing is possible, you will do it. Now, one doubt that will come to someone of you will be, suppose we have AJ and suppose we have AI, right? We have multiplied AI to 2 as many times as we have as it was possible. And now AJ minus AI is our minimum answer. Now some of you might think that can we do something like we can do 2 ki power AI, 2 ki power, let's say, can we do something like this? Can we multiply 2 ki power x to AJ and can we multiply 2 ki power y to AI such that this particular value will now decrease. This particular value is less than or less than will somehow become less than what a j minus ai that was mentioned here. So first of all, the first thing that you need to notice is that this x and y for this x and y For this to be possible, the first thing that you need to notice is x should be less than or equal to x should be less than or less than y. Exactly less than y. Right. Suppose x is equal to y, we can simply take 2 keep r x common and see that there is aj minus ai left inside. Okay. And since aj minus ai was already there and we have multiplied some 2 keep r x with it, then this will increase. This will not be less than aj minus ai that was initially there. Okay. So, okay. So, what if we take some x that is less than y and we multiply 2 keep r x to aj and 2 keep r y to ai? This we can do, right? But the thing is that if you assume this, assume that 2 keep r x you took common, assume that you took 2 keep r x common, and this is 2 keep r x into some aj minus ai into 2 raised to the power y minus 6. This thing is less than equal to aj minus ai. And you also know that this value should be greater than 0 first of all, okay, for this to be valid equation, because we don't want to make ai greater than aj right now. Right now, what we are focusing on is we need to decrease the difference between these two elements. Okay, we don't want to change their order. We just want to decrease the difference between these two elements. So you can see this by bit set also. You can prove by contradiction also that if you want to do something like this, where y is greater than x, you can take 2 keep r x common and you will see something like this, right? You want this to be less than or equal to aj minus ai. And the thing that you will notice here is for this thing to be true, first of all, this is greater than 0. So if you just put this particular thing as greater than 0, then what we'll get is aj is greater than ai into 2 raised to the power y minus 6, where y is greater than x. So this is 2 key power something, 2 key power something that is greater than 0. And if you see this, if we were able to do this, then we could have done it earlier only, right? What we assumed here was aj and ai are as close as possible, right? Now you cannot multiply ai by 2 further, right? If you multiply ai by 2, it will become greater than aj. That is what we assumed earlier, right? That is what we assumed earlier. But as we can see, it is contradiction. So yeah, so for any ai and aj, if you want to keep aj as a greater element and you want to keep ai as a smaller element, you can just multiply ai by 2 and bring it closer to aj as much as possible. That's what you can do only, right? Now another thing is that we were given an array, right? What we have done till now is we found the max element that was some aj, let's say, right? And we took every ai from this array, we took every element of this array and we multiplied it by 2. We did ai is equal to ai into 2, while this while ai into 2 will be less than or equal to aj. If we did this, till now we have done this. And now what is our answer? Our answer will be again, we will find a minimum and aj is our maximum. This is j. Aj is our maximum. We will find some minimum and that is the answer currently. But that's not the final answer. As if you can see here, in this case, it's okay. In this case, 231. In the case 231, we have 3 as the largest element. What we can do is we can multiply 1 by 2. So 1 into 2 will be 2. We can replace 1 by 2. And now the minimum difference will be 1. Right? Minimum difference here is 1. So for the first question, the logic works fine. But if you see the same thing here, right? You see the same thing in this question. Suppose I take only 3, 57, and 10 for now. Suppose I take only 3, 57, and 10. Just a second. The answer was 44, 20. Yeah. So in this particular case, or if you take this 57 and 10, if you do 10 into 10 and then again into 2, you will get 40, right? If first you will multiply 10 by 2, you will get 20. You can again multiply it by 2, you will get 40, right? And suppose, sorry, this is not 57. Let's say this is 67. To explain it, right? What's the difference right now? The difference right now is 27, correct? Now what we can do is we can increase this 40 further, right? We can increase this 40 further and it will become 80. And now the difference between these two elements will be 13. So what we can do is we can just keep the max there itself and we can increase its previous elements by 2 so that our max minus min, maximum element minus minimum element will change. Okay. So now what we did was we first of all multiplied AI by 2 as much as possible. We sorted it. Okay. We can sort it, right? We don't care about the occurrences, the way in which the elements are occurring. We only care about what the elements are. Okay, so we can simply sort it. So after sorting, we have got some array where this is the minimum element, this is the minimum element of the array, this is the maximum element of the array, and there are some elements also in between. So now the current answer is simply max minus min. But what we can do further is, as we saw here, we can multiply this min by 2 and it will become greater than max. If multiplying min by 2 doesn't become greater than max, then we would have already multiplied it by 2 earlier. So multiplying minimum element by 2 will make it greater than max, right? So min into 2 will come here. And if we do this operation, let's say this min is A1, there is A2, there is A3, and there is then AN. Okay. And this is the smallest element, this is the largest element. If we multiply A1 by 2, first of all, it will become greater than AN. So let's say A1 into 2 is here. Now, what is the maximum minus minimum? The maximum minus minimum is now, sorry, the maximum minus minimum is now A1 into 2 minus A2. Correct? This is what the answer has become. So, what we can do is we can keep the answer as AN minus A1, or we can update the answer as this. Right? Now, again, what we can do is we can multiply A2 by 2 further, and what we can do is A2 into 2 will come after A1 in sorted order. Now, the answer will be A2 into 2 minus A3. So, A2 into 2 minus A3 we will do. That's our answer. We can do this. In the similar fashion, we can convert our answer to A3 into 2 minus A4. Right? We can convert our answer to A4 into 2 minus A5. In similar fashion, we can convert our answer to AN minus 1 into 2 minus AN. Right? Uh, and yeah, first possible answer was always there, AN minus AN. These are all the possible answers that we can make right now. Yes. So we will simply take the minimum of all of these answers that we are able to make, and that will be our answer. And yeah, one more thing that we need to see here is after we multiply an minus 1 by 2, the array will look like an is here, right? A1 into 2 is here, A2 into 2 is here, and then A of n minus 1 into 2 will be here. Now, if you are thinking, can we multiply an by 2 and put it here again, and the answer will be an into 2 here, and then an into 2 minus a1 into 2. So, this is what we proved earlier, that we will that we will not multiply the largest element by 2 anytime. So once the largest element is in the beginning of the array, we will terminate it. So these are all the possible answers that we can get. We will take the minimum of all of them. We will take the minimum of all of them, and that will be our final answer. So let's see. implementation also. Okay. You took input and then AI. We found the max element, whatever the max is, code it in MX. And now for all the elements in the array, what we did was we multiplied AI by 2 if we can, right? We multiplied AI by 2. If after multiplying it, it will be less than equal to max, right? So we multiplied AI by 2 whenever it is less than equal to max. We did it. Okay. So the time complexity for this will be simply log AI. So the overall time complexity is n log n for sorting and n into log AI for this for these operations. So the overall time complexity is also not an issue. So yeah, we multiplied AI as long as we can, and then we what our answer will be finally after doing this, our answer will be simply max minus AI. What is max minus AI? The maximum of this, or you can simply do simply what you can do is not calculate the answer here. You can simply sort the array and then say that yeah, our final answer will be an minus 1 minus a0. And then after that, that was our initial answer, right? An minus a1. If we say that it is 0 index, then an minus 1 minus a0. This will be our final answer. And now we can convert our answers to these particular values also. So for that, we run a loop. We simply did answer will be either answer or 2 into ai minus a of I plus 1. That's what we can convert our answer to. So yeah, that will be our final solution for this problem also. I hope it's clear to everyone. Now let's move to the fourth problem. Now, for an array A of size n, we can create a graph B consisting of n vertices. Just a second. So for an array A of size n, we can create a graph G consisting of n vertices by adding bidirectional edges, I comma A, right? And we can say that the array is good if the array corresponds to a graph that is fully connected. And we need to find a rearrangement of the given array such that the rearranged array is good and output minus one if no such array exists. Right. Okay. So now first of all, again, let's understand what the problem says. Fourth question. You are given an array of n integers. You can rearrange this array such that there is a vertex between a1 and 1. A1 and 1 are connected. A2 and 2 are connected. A3 and 3 are connected. That is what you can see here, right? Similarly, an and n are connected. So after connecting all of these edges, we need to get a graph that is fully connected. And we need to find an arrangement for that. So suppose these are our nodes. This is our node 1, node 2, node 3 is somewhere here, node 4 is somewhere here, node 5 is here. For now, let's say there are only 5 nodes. So whenever you get an array, let's say the array is 2, 3, 3, 4, 1. Okay, so we can connect 1 by 2. Then for 3, 3 can be connected to 2. 3 comma 2 is connected as basically. Now 3 comma 3 is also connected. And then 3 comma 1 is connected, 3 comma 4 is connected, and 5 is connected to 1. So after doing all of this, what we want to do is we want to get a fully connected graph, right? So also we can see that we have n edges in this graph as there are n values and we are connecting ai comma I. So we have n edges. So using these n edges, we want to connect the graph. And if it is possible, we need to output that particular connection, that particular rearrangement of the array. Right. So first thing that you can notice here is to any one element. Of course, we will try to ignore, try to not do this particular thing, or we will try to not do a self loop. Okay. So for all the elements from 1 to n, there will be one edge to it that is at a1. Suppose for any I, for any I, one edge from I will always be there because there will be an AI from I and AI will be connected, right? So one edge from any I will always be there, right? For any vertex I, one edge will always be there because there is an element at AI. Okay. Also, you can store these AIs, all of the AIs you can store in a map. So suppose you made a map and you stored some AI and AJ and AJ and its number of occurrences also. It's count here, it's count here, it's count here, right? So you have stored the number of times AI has occurred, the number of times AJ has occurred, the number of times AK has occurred, right? You have stored this in a map. Okay. So now what we can see is the map contains all of the vertices that that can connect any element to itself. That can connect any element to itself or its component, you can say. Suppose this AI is a part of a component. This is component of a graph. And suppose AI is a part of this component. And suppose there are some count is three for now. And there are three edges from AI. Why there are three edges from AI? Since AI has three occurrences in array, then wherever these three occurrences of AI will occur, all of these indexes, the indexes where this AI will occur, will be connected to AI, right? So suppose AI was something and it had three occurrences, and wherever these AI will occur, it will be connected to AI, right? So suppose for now AI is a part of a component. What we can do is we can take any three values and we can connect it to AI, and simultaneously it will be connected to the component which has AI also, right? So doing this, we need to construct a fully connected class, right? So what we can do is we will take any element from the map that has some that has some edges, right? Suppose in the map there was one, then there was three, then there was seven, and one has two occurrences, three has three occurrences, seven has some four occurrences. So what we can do is we can take one, and we can connect all of the other numbers from the map to one. That is, we took one, we had two edges starting from one. We can connect three to one, we can connect seven to one. Okay. We connected one to three, we connected one to seven also. Okay. We took one, we connected one to three, and then we connected one to seven. So what are we doing by this? We are making a component that has all elements of the map. And what the map is storing, this is the map, right? This is the map of AI comma count, AI comma count. This is the map of AI comma count. So the map is storing all the vertices that we can make edges from and the number of edges that we can make from that particular vertex. That is it, right? As we are connecting AI with I, we are doing, right? So if there is any AI, we can make a vertex from AI to that particular index, right? So from one, we can make two edges. So what we can do is we can simply first of all connect all of the elements of this map using the number of edges that are required. So suppose there are three elements in this map now. Connecting all of these three elements will need two edges. If there are some five elements in the map, If there are some five elements in the map, connecting all of the elements of the map first will take four edges. And then after connecting all of the elements of the map, after connecting all of the elements of the map, what we can do is we can use the remaining edges. Whatever edges are remaining, we can use those remaining edges for our remaining vertices, right? Some like in this case, 4, 3, 7, 6 to 9. There are nine vertices, right? There are nine vertices: one, 2, 3, 4, 5, 6, 7, 8, and 9. Now what we know is we can two edges starts from one. So there are two edges from one, there are three edges from three, and there are four edges from seven. Okay. And we need to connect this all of these vertices so that it makes a fully connected graph. So first of all, what we need to do is we need to connect these particular values that have edges. Okay. So for that, what we can do is use we can take any of this. Suppose we took three. Okay. We take these two edges of three and we connect it to seven. So three is connected to seven and three is also connected to one now. Okay. And three has one edge remaining. So now we can see that 3, 1, and 7 are in one component. And now we can use all of these edges. We can use all of these edges to connect the remaining elements, right? So 1 has two edges. We can simply take 1's two edges and connect it like this. If 3 has one edge remaining. We can take 3's edge and connect it like this. 7 has four edges remaining, right? 7 will be connected to 8, 6, 5, and 3. Why 3? A3 was nothing, right? At the third index, there was no value. So the last element will go to 3, right? So if you notice, if you notice, we took one element from the map, we used all of its count or all of its edges to connect some other elements of the map also, right? Suppose one, let's take another example. Suppose one has one edge, two has two edges, then there is four, and four has also some two edges, and then there is five and seven, two and eight and nine also that have some like 10 edges, right? So if you start from one, you can take this first edge and you can use it to connect two in our component. Okay. So now the one is gone. Now in this component we have two edges, right? Two is also part of the component now. So these two things we can use this also. So these two edges are also the part of the component. Now we can use these two edges to connect another elements also in our component. So out of these two edges, one I will use to connect four. Okay. Now four is also a part of the component. We have another edge starting with two. We can take this edge and we will connect another element. Right. So we connected five also. Now we have two edges of four. We will take one edge of four. We will connect one edge will remain and we will connect eight also in our component. Again, we will take one edge of four and we will connect, let's say this seven is not here. And we will connect 10 also to our component. After doing this several times, all of the elements of the map, all of the elements of the map will be in one single component. And after this has happened, we can use the remaining edges of the component or of the map to connect all of the remaining elements. Yes. 3 is remaining, right? And 6 is remaining, 7 is remaining, and some 21, 22, 23, 11, 12, 13, all of those elements are remaining, right? So we will use all of the remaining edges to connect these elements. So we can see here that we can always create a connected component. We will take one element from the map. It will correspond to at least one element. Since it is in the map, it will have at least one edge, right? So this one edge will include one more element to our component. And since one more element is added, then at least one more edge is also added to our component. So we will continue doing this. And yeah, we will continue doing this. And doing this, we will be able to connect all of the elements that are in the map or that have edges. And after doing this, we can use the remaining edges to connect the rest of the numbers. Connect the rest of the numbers to our component. Right. If anyone has doubts, please ask. So let's just see the code, I guess. Yeah. So we took the inputs, we stored it in the map. The element AI has M of AI edges, right? That is what we are storing. And this B is the rearrangement. It is one index. Okay. So what is this set S1, S2? It is a, I am just implementing like this. So I first of all took one element, right? First of all, I need to connect all of these elements of the map only, right? First of all, I want to connect all of the elements in the map. So I will start with the one element. I will say that this element is a part of the component. I will use its edges to connect as many elements as possible in our set, right? So S1 will contain the number of elements that are the part of our component. S2 will contain the elements that are not currently the part of our component but are in the map that contains the edges, right? That's what we need to do first of all, right? So in S1, I first of all inserted any one element of the map. I took S1, I took S2, right? So in S2, I inserted all of the elements of the map. All of the elements that have edges are inserted in S2, right? So I need to start with any one element. So I will take the first element from S2. I will insert it to S1. I will erase it from S2. Now what I need to do is I need to connect, I need to connect all of the elements that are in S2 to the elements that are in S1. Right. So I will take the first element of S1. Right. What is X? X corresponds to the first element of S1. So while we have remaining edges in X, we will use it. If there is no edge remaining in X, we will erase it from S1 and we will simply take the next element from S1. There will always be one element remaining in S1. We have proved it earlier. And yeah, we will simply connect X to Y. So By will be X. We are connecting X to Y, right? X was the element of the array. X was one of the AIs. So after rearranging, we will put By equals to it, where Y is an element that has edges. So after doing all of this, that map that we talked about earlier, the map that has edges will be connected, right? And after doing this, all of those numbers that have remaining edges will be stored in S1. So I will use all of those edges from S1 to fill the remaining area. And it can be filled in any order as it doesn't matter now. Uh, So that was the construction for this particular problem. I hope it's clear to everyone. Yeah. Now let's move on to the last question. I was not able to solve the last question, so I asked it in my and Okay. So the last question says that you have an array A, and any array A is called beautiful. An array A is called good if it holds the following condition, right? For every element, for each index I, and for each value x, such that x is less than ai, there should exist an index j satisfying the following condition. That is, what is the condition? Uh, there should exist an element before I that is equal to x. And this should be true for all x less than ai. Okay. And now you are given an array of n integers, and we need to find the number of good subarrays. So first of all, let's understand what the problem says exactly. The problem is, first of all, what is a good array? If you are given any array A, and if there is an element AI, right? So for all x that is less than AI, for all x, there should be an element that is equal to x before AI, right? Suppose AI was 4. So how many x's are there less than 4? 1, 2, and 3. 1, 2, and 3. So there should be the elements 1, 2, and 3 before 4. Right. In the array, 1, 2, and 3 should occur before 4. At least one times. At least one times 1 should occur before 4. At least one time 2 should also occur before 4. At least one time 3 should also occur before 4. That is what the question is asking. And this should be true for every index value. Right. If we break it down further, what you will see is the first element will always be 1. Why? If the first element is 2, or if the first element is any other element other than 1, then we will need all of the elements before it, all of the elements less than it before it, right? Let's say it's 2. So we will need a 1 before 2. So since it is the first element of the array, there is no element before 2. So we will need the first element of the array to be 1. Then the array can have 2, right? Then here it can have 1, 2, or 3, anything, right? Here also it can have 1 or 2 also. So the first element is 1. The second element will be anything. So what we are doing basically here is, um, again, for any AI, all x should be present before that AI. Okay. So for this, now the first greedy thing that you will like to notice is, for any AI, right? It's just a second, guys. Yeah. So for any AI, the first thing that we need is, we need an AI minus one before AI, right? We need an AI minus one element before AI. And this thing in the array, this thing should also be good, right? This index should also be good. And for this index to be good, A of I minus 2 should also be present in the array. And then for this AI minus 2 to be good, A of I minus 3 should also be present in the array. So a good presence of AI minus 1 will ensure that A of I is also, this particular index is also good, right? If AI is good, AI minus 1 should be there, AI minus 2 should be there, AI minus 2 should be there, and that's what we need to ensure. Yes. So for that, what we can do is, we will uh, we will simply see the number of subarrays starting with one particular value of L. Right. We will see the number of subarrays starting with one L. Okay. starting with 1. Right. So, and yeah, if a sub is starting at L, of course, AL should be 1, right? Because for any good array, the first element is it needed to be 1. So, what we can do is we can simply see that whenever a new elements come in the array, right? Suppose first element was 1, right? Then we got an element 2. So we can say that yeah, that 2 can also be in this particular segment only. Okay. And now since now suppose we got a 3, right? So we can say that this 3 is also in this particular segment only. Now again, if we got a 2, we see that 1 is present in this in the segment that was continuing. So we can say that yeah, this particular 2 can also be included in this segment only. That's not an issue. Uh, the issue will be there when any element greater than this element will occur, greater than 3 plus 1 will occur. Suppose 5 occurs. Okay. So for 5 to be good, for this particular index containing 5 to be good, there should be a 4. Okay. There should be a 4 before 5. And as we can see that segment, this segment does not contain 4. Therefore, we cannot continue this segment further. Okay. We cannot continue this segment further. This segment was something like this, right? 1, 2, 3, and then again 2, and then came 5. If we start with this one, if we start with this one, we can say that yeah, it can go up to here, it can go up to here, it can go up to here, it can go up to here. But now it cannot go further than this because there is a 5. There is a 5. And 5, for 5 to be good, for the index with 5 to be good, we need a 4 before it. 1 and 2 and 3 are there, but there is no 4 before it, right? So for 5 to be good, we need a 4 before it. And as we can see that there is no 4 before it, we will say that yes, this particular segment needs to be ended. This particular segment has to end here. Okay. So we will simply build upon this logic only. And that's how we'll continue to the final solution. Right. So we had one segment, right? Suppose we had something like 1, 2, 3, 4, then 2, and then 3, something like this. Okay. Now suppose the 1 comes again. Okay. If there is another one that comes, so what we can do is we can again start a segment. And this is not a different segment. This is the same segment, but we are keeping it different because we can start a segment from this one also. We can start a segment from this one also. And both of these are connected. There is no divider between these two segments. Okay. So we will show these segments only. Okay. So first of all, there was this segment, then a new one came, so a new segment starts. Okay. A new one came, so a new segment starts. So this new segment is also something like 1, 2, 3, 2, right? And now let's say a 5 occurs. What will happen is we will see that this segment that started from this one, the segment that started from this one, not be continued further. So we will need to break this segment, right? So we will simply break this segment. But the segment before it, but the segment before it, this segment contains a 4, and this segment is a correct segment. So this segment contains a 4. So we can actually add R5 to this segment. We can actually add R5 to this segment, right? What we can do is we will erase this segment. We will add the contribution of this segment, or you can say the answer that this segment had. Uh, what is it? It is basically four, right? Starting with one, ending here. We can do four subarrays. Starting with one, ending at one, ending at two, ending at three, and then ending at this two. So the length of this segment will be added to our answer. And now what we can do is we can add our five to the segment before it. This segment can be continued after this, right? This segment was also stored. It can be continued up to this one, it's two, three, and two, and then this five also, right? Sorry. Okay. Yeah. So this segment can be continued up to this one. So we will add five here, and then we will continue this segment, and then we will move further in the array, right? I hope it's clear whatever we are doing. And now, why this thing works? Why this thing works? Suppose we had a segment of one, two, and three only, right? I mean, three was our maximum element in one segment. Now let's say another segment came, and now let's say there was a break six. Okay, and let's say this six is able to continue in this segment, but if you see, this six will not be able to continue in this segment. But actually, that's not true because if the six can be included in this segment, that means there was one, two, three, four, and five in this particular in this segment. In the second segment, let's call this the second one. That this is the first one. So if we can add the six to the second segment, then we can use these fours and fives in the first segment also, and say that yeah, this one, two, three can be continued further, right? So what we are doing is whenever we got a new one, we are starting a new segment, and we are saying that yes, we can continue this segment. We can use the previous segment also, the segment before it that is still there, right? So this is what we are doing. So whenever we get a new one, we will start a new segment. And yeah, whenever a new element comes, if this new element, suppose this is the max of this particular segment. If if this particular new element is less than equal to max, then we will say that yeah, this new element can be included in this particular segment. And if this new element is equal to max plus one, this particular new element is equal to max plus one, what we can say is, yeah, we can include this new element in this segment in this particular case also. Now, mx was there in mx was there in our segment, and mx plus one has come. So to include mx plus one in our segment, we need all of the elements from one to mx in the segment, right? And we can see that one is there in the segment, and all the elements from one to mx are there in the segment. So yeah, we can include mx plus one also in our segment. So if mx plus one comes, then also we will simply date our mx to mx plus 1 and continue our segment. Problem will come whenever there is an element greater than mx plus 1, right? The problem will occur whenever a new element greater than mx plus 1 occurs. In that case, what we see is we cannot continue this segment, so we will simply break this segment, right? We will break this segment and we will move to the segment that was before it and that has not been break till now, right? And for this segment now, we will see that if we can add this new element to the segment or not. If we cannot, we will simply break this segment also. We will do this as uh, until we will get any segment that can be continued, right? Yeah. So that was the logic. We will basically store a stack or vector also. You can do this in both. We will simply store a stack of int comma int, right? we will simply store a stack of int comma int. What does these ints represent? This represents the index of this int comma int represents a segment. Okay. The first int represents the index of start of the segment. Okay. And the second int, this represents the max element of the segment, the current max of the segment. Okay. So we will have a stack of pair of int comma int. That's what we will store. So now, uh, let's say that we are at some index 8 and we got some element 5. And we have our stack. This is our stack. And we have, let's say, a 0, comma 3 here, then a 2. No, no, 2 cannot come here, right? And a 4, comma 4 here. 4, 5, 6, 7. Yeah, 4, comma 4 here. Okay. So we will see that, yeah, at 8th index, we got 5. Can we add 5 to our previous segment? If yes, since it is 4, we can add 5, right? So we will add 5 to our segment. We will update this max to 5. Okay. If we cannot add 5, let's say this was 4, comma 3 only. Okay. And this was 0, comma 4. Let's say this was the case. And let's say now a 5 comes. And at index 8, okay, we see that there was okay, 0, 1, 2, 3, 4, 5, 6, 7, 8. These are the indexes of the array. Okay. And there are some values also. So one index started at 0. So and one index started at 4. And currently we are at the index 8. Okay. At index 8 we got 5. And we see that the previous segment, if we are not able to add 5, what we will do is we will simply break the segment. Okay. How we can break the segment? We will see that yeah, 4 was there up to 7. The index that started at 4 was there up to 7. So how many ways can we end the segment starting at 4? We can end it at 4 only. We can end it at 5. We can end it at 6. And we can end it at 7. So we can end it in 8 minus 4 ways. So we will simply add this to our answer. We will add this thing to our answer. And we will remove this segment from the step. Okay. So now what segment do we have in our set? We had a segment that started at the index 0 and that has a maximum element 4. Now 5 comes. Now 5 comes. And we can see that we can add 5 to our segment. We will add 5 to this. We will add 5 to this. And this segment will still continue. And if let's say this 5 was not there, there was 6, then this segment would also have broken, right? If there was 6 here and this was 4, then we see that, yeah, we cannot continue this segment. So we need to break this segment also. We got 6 at 8th index. This segment started at the 0th index and has continued up till now. So in how many ways can this segment be broken? This segment can start at 0. Of course, it starts at 0. It can end at 0 only. It can end at 1. It can end at 2, dot, 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 and up to it can end at 7, right? So for this index also, what we can do is we will simply add 8 minus 0, that is the current index minus the index at which the segment started to our answer. So this was the logic to the fifth question of our debate. Let's see the code also. The code is not very optimal. In the code, there are a few things. First of all, here we are storing a starting index and max only, na? This max is stored using a stack. So I guess you can actually just change it if you want. So let's see. We first of all took n, uh, like this is our inputs. We took all of the elements as our inputs. We made up stack. We made a stack of long, long, comma, long. History, right? Let's just code it from the very beginning. It will be easy. See, so we took input of n. Where are we? What are the inputs? N and by array. Right. Okay. Now we will take our array as input. Right. Now what we need is we need stack of pair of in comma int. Let's call this stack as P. And now what does this stack represent? This stack represents the start index of segment. What is a segment? Segment that starts with one, right? Comma max element of segment, right? That's what our pair stores. Okay. So now what we'll do is we will simply see the AI, right? And while we'll also take an answer, yeah. And while our stack is not empty, while our stack is not empty, and stack dot top, जो sorry, yeah, stack dot top dot first जो हमारा था, capital F is first, yeah. So what is first? First, what was the first element of the stack? So of the pair, it was the start index of the segment, right? So it is stored in the array, right? So just a second. What am I doing? What am I doing? Yeah. Sorry. We need to check the second element, right? What was the second element? Second element was the maximum element of the segment. Okay. So while our stack is not empty and the maximum element of the previous, say, previous segment plus one, that's what we can store in our segment, right? Is less than. While this particular thing is less than what? Is less than our current element, is less than AI, then we need to remove that particular segment, right? And before removing that particular segment, what we will do is we will simply do an answer plus equals to I minus sp dot first. What was the first thing? It was the index at which the segment started. So this is the contribution of that particular segment. And now we will just remove the segment. So sp dot pop. Sorry. Sp dot pop. Right. That's what we will do. Correct. And now also we need to check one thing. If stack is not empty, if stack is not empty and the second element is equal to AI, then what we'll need to do is, let's say, if this thing is equal to AI, what we'll need to do is, we will need to update our last segment, we'll need to update our last segment's maximum element, right? So, yeah, we will need to update our last segment's maximum as it is updating to AI now. Yeah. So in that case, we'll do simply sp.pop and we will push sp.push. We will push, yeah, before doing, yeah, temp is, okay, that will be our temp. Yeah. And we will insert temp comma AI again. That's that, right? After doing all of this, after completing our iteration, we will again just look at the stack and whatever segments are still not terminated, we will terminate those segments, right? So while not sp.empty, yeah, what we will do is we will simply do answer plus equals to n minus, right? And that will be our answer. Let's see if the code works fine. Wait a second. What am I doing? Oh, yeah. Whenever a one comes, we need to start a new segment, right? So if a one comes, if AI is equal to one, we need to start a new segment, right? Then what we'll do is we will start a new segment. So sp dot push, uh, it is starting at the ith index and the maximum element is one currently, right? So I hope this should work fine. Yeah, I guess I messed up the implementation somewhere. Uh, ये कुछ कर लग रहा है, मुझे मीटिंग लग रही है, बड़ा एलिमेंट आया तो मैं मतलब इस सेगमेंट है, इस सेगमेंट को मैं टर्मिनेट कर दूंगा, राइट? इस सेगमेंट को मैं टर्मिनेट कर दूंगा, आई माइनस सिक्सटी का टॉप प्रोटेक्ट में करूंगा, एचपी का टॉप करूंगा, okay, I guess I don't know what's wrong, but the logic behind this code is correct. You can try to implement the same logic on your own, and yeah, that was that was it from my side. Thank you, everyone.